Chapter 7.2, Volume. Today we're looking at the disk method. Later we're going to look at the washer method and cross sections. So first off, what are we doing? How are we finding volume? Right? We're going to take a function and we're going to rotate it around an axis. In this case we have a line and we're going to rotate around the x-axis. This is kind of the concept behind a lathe. In a lathe you take a chunk of wood or a chunk of metal and you spin it really fast and you cut out some pieces and you get a nice little shape that's symmetric about the axis. You've rotated around, and we're going to find like the volumes of these chunks. What it looks like is kind of like here, we're going to rotate the function around. You can see we got the line swinging around the axis, and as it swings, it cuts out a shape. We're going to find out the volume of that shape. Here's another example. All right, here's an example of more of a curve shape. Okay, as we swing that around, it's going to make kind of this wheel type shape. Kind of a messed up weird wheel, but a wheel nonetheless. All right, so we're going to look at how to find the volume there. First thing we're going to do is we're going to take it, and we're just going to look at a small piece of it. So let's say this is our function, right? And we want to find out what is the volume when we rotate this region of it around the x-axis. Well, instead of doing it all at once, we're going to do it in slices. So we're going to slice it up. Just like we did area in small rectangles, we're going to do volume in small rectangles. So we're going to take this shape, or just this piece right here, and you're going to rotate that around. Once you rotate that around and you take it out, you get kind of a disc shape. And the volume of the disc is going to have this face right there, the area of that face, times whatever the width is. Well, the face is a circle, so the area is going to be pi r squared. And our width is going to be w. So each slice will be pi r squared times w, and you want to take and add up all the slices in this area, or in this region. Well, as we do that, we want to have it be as accurate as possible. So we're going to have the change in x on each of these slices get smaller and smaller and smaller. All right? And then the number of slices is going to get bigger and bigger and bigger. What other what other concept have done this for us? Well, when we did area, we did the integrals. So really what we're doing is we're going to take each disk, pi r squared delta x, and we're going to let there be infinitely number of disks of infinitesimal width. And it's going to end up being where the delta x becomes dx, and our radius will be a function. So our volume, when we have a horizontal axis of revolution, will be pi r squared dx from a to b, where r must be in terms of x. Or if, say, you rotate around the y-axis instead, well, then you're going to do pi r squared dy from c to d, where r is in terms of y. Right? So let's look at a couple examples here. Right? So let's rotate the shape square root of sine x around the x-axis. So that's this shape right here around the x-axis from 0 to pi. All right? So first off, because we're around the x-axis, our shapes, our discs are going to stack up perpendicular to the x-axis. So it's going to be dx. Anytime you're perpendicular to x, you're dx. So our volume will be pi r squared dx. Now we're going from 0 to pi. Now our radius goes from the axis of rotation, which is 0, up to the function, which is the square root of sine. So radius squared will be pi, or radius squared will be the square root of sine squared, which is sine of x dx. Now that is certainly something that you could integrate by hand, but I want to show you how to do it in the calculator. Why don't you pause the video, try it by hand, and we'll check it in the calculator. So first, what you need to do, make sure your calculator is in the correct mode. It needs to be in radians. Can't emphasize enough how important that is, especially if you're taking physics as well. All right, so we got it in the correct mode. So we're going to integrate the sine of x. So we'll do math, function integration, which is the 9th choice in the menu. We're going to go from 0 to pi. Our function is sine of x, because that's the radius squared with respect to x. So we do that, we get 2. So this part right here is 2, so the volume is 2 pi. Now you could have just in your calculator multiplied it by pi as well, but that's a matter of choice. Do it or don't do it, it's up to you. All right, let's look at another one. Find the volume of the solid formed by revolving the region bounded by f of x equals 2 minus x squared and the line g of x equals 1 around the line y equals 1. All right, so this is our region. We're no longer along the x-axis, but we've shifted up 1. All right, so because we're going around this axis, we stack them. We're still going to be stacked perpendicular to x. So it will still be dx. So our volume will be pi from a to b of r squared dx. All right, we're going to need to find our intercepts. So let's do that first. All right, we'll graph 2 minus x squared. We'll graph y equals 1. I think on this one we can zoom to a decimal window and it should show up quite nicely. It appears to be balanced, so if we find the right intercept, we'll have the left intercept. So we'll trace, intersect, first curve is y1, the second curve is y2. It looks like the intersection's about 1, so I'll guess 1. And the intersection's 1, 1 for right here. Because it's balanced, they're both even functions. That one will be negative 1, 1. So our integration will be pi from negative 1 to 1. Our radius goes from the function down to the line 1. So our radius in this case is 2 minus x squared minus 1 because we don't go all the way back to the x-axis. So our radius squared with respect to x. All right? So there's the setup. And again, you can certainly integrate that by hand. Nothing's stopping you. Why don't you try that? And then we'll do it on the calculator. All right? So on the calculator, we'll get to a clear screen. Again, we're going to use Math 9. Our limits are from negative 1 to 1. And our function, we need to group it because it needs to be squared. Our function will be 2 minus x squared minus 1. You could have certainly simplified that if you chose. With respect to x, will give us 1.0666. I prefer fractions, exact answers. So that ends up being 16 over 15. Remember, it needs to have pi in it. So this volume is 16 pi over 15. And if you wanted estimated answer, you can sure go ahead and multiply by pi. So in conclusion, the disk method for finding volume. When you're rotating around the x-axis, or something that axis is horizontal, it's going to be pi r squared with respect to x from a to b, making sure r is in terms of x. If you're going around the y-axis or an axis that is vertical, it's pretty much the same thing, except your r needs to be in terms of y, and you'll be with respect to y.